Friends, let us derive the relation between the induction motor rotor torque. The torque which will produce based on slip speed, based on reactance value, based on voltage induced in the rotor, we discussed in the previous classes. As we know that it produces torque based on its load. Just what we have seen previous classes, recalled once again. So, we have derived that here this is a stator as the stator winding, it given to the 3-phase supply, it producing, that is the P1, the P1 is equal to root 3 VL IL cos phi, and this total energy utilized for stator losses and stator output, that is P2. The stator losses further in the stator copper losses, stator iron losses. Okay. Then so total input minus stator losses, that is equal P2. Then P2 is further utilized for rotor copper losses, stator, the rotor iron losses were neglecting, that is called mechanical power developed in the rotor. Okay. Whatever the P2, that is the stator output, rotor input. So, that is utilized for copper losses and the total mechanical energy developed in the rotor. Further from this one, so one friction and windage losses taken place, then we are going to the P out, net output of the motor. Okay. These are the stages, power flows from stator to rotor. Last class, based on these 3 factors, so we calculated how the torque is developed. This is the PM, mechanical power developed. So, mechanical power developed is equal to, we know that omega into angular velocity into torque. So, the torque is equal to 2 phi ns divided by 60 in RPS into torque. So, we calculate this one value. Now, at the same time the torque, so we derived the equation, some constant into S into E2 standstill voltage whole square into R2 by R2 whole square plus S x2 whole square, we derived this equation. This is the torque equation under normal condition. Okay. This is the full load torque at full load, we can write it the full load torque. This is the first equation. Now, I want the torque under starting condition. So, starting torque are equal to TS. Starting torque is called, I can kept S is equal to 1, I can K into E2 whole square R2 by R2 whole square plus X2 whole square. This is the second equation. This is the full load torque, this is the starting torque. At the same time, we derived T max torque also. Okay. T max torque we calculated. So, at what is the condition? S is equal to R2 by X2, we calculated that. So, we derived last class then some K into, so E2 whole square by, we write 2x2, this is the equation. Okay. So, you can write it this one, E2 square this one, this is the third equation. From the 1, 2, 3, I am going to create the relation between the 3 categories. One is the full load torque, so that is called K into, what is the value here? So, K into S into E2 square by R2 into this value, Ts is equal, S is equal to 1, T maximum is equal K into E2 square by 2 into X2. So, from these three equations I am going to derive the relation between these two. What is the relation? Now I can take the relation between we can write it the T full load torque, that is equal at slip full load torque, and we can write the T maximum. Okay. So, just you take it, T is the full load torque and T is the T max. What is the relation? I am going to derive the equation. That means, what is the equation? Equation 1 and equation 3, just we have seen here. What is the relation between the full load? Relation is the maximum. Next, what is the this relation, this one, this and this I will see next. These are the two relations. Okay, then write it. First, you can write the equations. What is that one? T is equal to, I know that, what is the equation? So, that is equal to, I am going to write it. T is equal to some K into S into E2 whole square R2 by R2 whole square plus Sx2 whole square. Okay, this is the first equation. And T max is equal to some same constant into E2 whole square by 2x2. This is the third equation. Okay. So, now you can write it 1 by 3. Write the 1 by 3. What is the 1? 1 is equal to T full load by T max. Okay. Then I am going to write it. What is that one? K into S into E2 whole square R2 by, okay, then R2 whole square plus Sx2 whole square whole divided by T max. T max same constant K into E2 whole square divided by 2 into x2. Okay. Now, what is the values here? This K value will goes, E2 square will goes. Okay. Then it will go, what will happen? So, simply write it. That is equal to, this will goes opposite, 2 into S into x2 into R2. Okay. This values divided by R2 whole square plus Sx2 whole square. So, these are we are going to get it. Now you can divide numerator and denominator by x whole square, x2 whole square. Okay. So, this value you are going to you can write the divide numerator and denominator by x2 whole square. Then what is the value we are going to? So, 2 into Sx2 R2 divided by x2 whole square. Okay. Similarly, divided by, what is the denominator and numerator? R2 this one. Okay. R2 whole square by x2 whole square plus Sx2 whole square by, you can write it the x2 whole square. Okay. Then, so you can take it, this will goes, then, so we are going to this one and this one will goes. Then I am going to write it in this equation, 2 into S into R2 by x2 divided by, here R2 by X2 whole square plus S square. Okay. Then here I am going to write it where A is equal to R2 by X2. I can write it. So, just like conditions slip. Okay. Then I am going to write it this equation. Okay. So, you can write it equation. So, this equation I am going to that 2s into A divided by this is called, I can write the A square plus S square. So, this is the equation I am going to get finally, that is called 2as by, okay, 2as by A square plus S square. So, that is equal to T by T max. So, this is the relation between full load torque and maximum torque. Okay, dear students. So, just use the simplification of this one too. Okay, same we can see in the that one. So, relation between the Ts and Tmax and full load torque. So, we taken this T by Tmax. So, substituted this values whatever the equation, that is the we taken here. Okay. So, numerator and denominator. So, this divided by this thing. So, we are going to get it. So, this value, and finally, so I am going to get it. This is the equation. This is called T by T max, okay, is equal to this value. So, it is useful in calculating the problems. Please remember these things. Okay. So, this is the one derivations. So, there is a relation between the starting torque and the relation between the full load torque and maximum torque. What is the relation? This is the 2as by A square plus S square, where A is equal to R2 by X2. Okay. So, this is the one relation. Similarly, we are going to do the another relation, that is the relation between the starting torque and maximum torque, we will see. Okay. Now, you can do that thing. So, now this is the relation. Now, in this case, I am going to derive the relation. What is the relation? So, that is equal to relation between T start, T max. Okay. So, the T starting by T max, I am going to do that equation. Okay. Same equation I can write it. So, previously what will happen? So, I record T full load, okay, T by T max, I written as a 2as by A square plus S square, this relation. So, T start, that means at starting torque S is equal to, what is the value? S is equal to 1, S is equal to 1. Substitute in this equation, that T start by T max, then I am going to get 2A, A is equal, what is the value? A is equal, S is equal to 1. So, here what A is, S is equal 1 into 1 divided by, so A square plus 1 square. So, this is the formula, 2A by A square plus 1 is the formula, we are going to get it. Simply substituting the slip is equal to 1 at standstill condition, starting at starting S is equal to 1, relative motion between the RMF and the rotor conductors is the maximum, that is equal to 1, or you can derive that directly. So, we know the equations. So, substitute simply. So, this is the one equation. Alternate method. So, you write the formula. So, what is the T? Normal T is equal to, you know that, K into S into E2 square R2 by, okay, R2 whole square plus Sx2 whole square. This is the formula. Then here starting torque. So, the T starting is equal to S is equal to 1, that's the K into E2 whole square R2 by R2 whole square plus X2 whole square. This is a formula. So this is a one equation. Okay. Now what is the T max? So we are going to calculate the T max. So T max is equal to some K into E2 whole square divided by 2 into X2. This is the second formula. So 1 by 2 we are going to get it. So 1 by 2, the T starting divided by T max, okay, is equal to T starting is equal to what is the value? So I substitute the value K into S is equal to 1, then E2 whole square R2 by R2 whole square plus X2 whole square, okay, divided by this value, write it. So what is the value? K into E2 whole square by 2x2, okay, then substitute the values. What is the value here? Okay, so what is this one? So your k value get cancelled, okay, E square and E square get cancelled. Then simplify this one, then I am going to get that. So here that will come to 2 into x2 into r2 by r2 whole square plus x2 whole square, okay. So this is the equation. Now similarly in previous cases, divide numerator and denominator with help of x square, okay. So divide numerator and denominator with x2 whole square. Then similarly previous cases, 2, so divided by, then we are going to the r2 by x2, okay. Similar previous case here, so r2 by x2 whole square plus here 1. So that is equal to where you can write it. So a is equal to r2 by x2. Simply substitute, that is equal to 2 into a divided by a square plus 1. So that is the formula, okay. The T start by T full to max, sorry, max. So this is the value, okay. So what is the finally we are going to get it? That is equal to T starting by T max is equal to 2a by a square plus 1. So this is a formula, so we derived, okay. So same thing. So previously that equation, if we substitute the full load torque by maximum torque S is equal to 1, we are going to the same equation, okay. So what we have done here, simply we taken the two equations, one is the starting equation, another is the maximum torque equation. So 1 by 2 we substituted and simplified, then we are going to get the, that is the relation between the starting torque and maximum torque. So we are going to put the 2a by 1 plus 1, this value, okay. So now you can see the in PPT. So here relation between this starting by T max, this is a divide numerator and denominator by this one. So we are going to get this one. So finally we got this equation, okay. So this is the equation. So Ts by T max is equal to 2a by a square plus 1. So what is the a is equal to, what is the a? A is equal to r2 by x2, okay. So these are the relation between the starting torque, full load torque, maximum torque, okay. Based on this one, so we are going to do the some problems, okay. So if you draw the graph, previously we have seen, so what is the graph we have taken? So we taken the graph here, this is equal to n speed, this is equal torque, then what will happen? Starting torque, it has some starting torque. Initially starting torque is go on slow on increasing up to maximum. After that it will goes to the this one, this is at a synchronous speed, this ms. So this is known as the T max. So at that condition, what is the torque? That is equal to S is equal to R2 by X2 at that the slip, at that condition slip. This is known as the, this area is known as the T start. Okay, this is known as the T full load torque. Okay, this is the T max. These are 3 points you should know. Okay, so what we have seen, the starting torque. So what is the starting torque? Depend upon the T starting torque. We see T starting torque is directly proportional to the R2. Here R2. If resistance added in the rotor circuit, starting torque increases. Okay, starting torque. But whereas the T maximum torque does not depend on the R2. What is that one? So here K into E2 whole square by 2x2. But there is no R2 terms here. So maximum torque is independent of the R2, but starting torque is dependent of the R2. Okay, so these are the some. So we will see the another analysis also with graphs in the next class. Okay, dear students. So we have seen what is the starting torque, what is the running torque, what is the full load torque, everything we have seen. Okay, based on this one, so we do the some problems. Okay, so this is the simple derivations. Please do remaining problems based on this concept. Okay, now let us do one simple problem. Okay, so then you can easily understand what is the significance of this maximum torque, full load torque and starting torque. Okay, let us take one problem that is a very simple. Here is one problem is given. What is that one? So we will do then this one. Okay, we will do. Here is one problem is given in the textbook. I take it. What is the problem? A 50 Hz. So here is one motor is given. Okay, 3-phase supply is given. So 50 Hz frequency is given and 8 pole P is equal to 8 pole machine. Okay, induction motor has a full load slip of S is given 4%. The rotor resistance and reactances are, so R2 and X2 is given. What is the value? 0.01 ohm for phase and this is also 0.01 ohms for phase is given respectively. Find the ratio of maximum to full load, ratio of maximum to full load torque. So that is a T max by T full load is equal to, what is the value? First case, and second case I asked that speed at which the maximum torque occurs. So Nm is equal to how much? So these two are asking. Okay, so motor is given, everything is given. So you are going to find that what is the ratio full load torque by maximum torque and the speed at which maximum torque occurs. That means here, so you know that there is a speed n, there is a torque. So we taken this one value. Okay, so here maximum torque. So what is the Nm maximum torque occurred at that condition. So I am going to calculate this one. Okay, So once again I will read, once again you can see it. A 50H 8-pole induction motor has a full load slip of 4%. The rotor resistance and reactance are 0.01 ohm and 0.01 ohm per phase respectively. Find the ratio of maximum to full load torque and speed at which the maximum torque occurs. Okay, dear students, based on these given factors, so I am going to calculate. We know the relation. What is the relation here? So here relation is the, you can see, the T max by T full load. So we know that relation. So here T full load by, so we have seen the T max, we have seen, okay, T max. Previously we have seen, what is the formula? 2AS by A square plus S square. This is a formula, but it is given the reverse. So 1 by that we can write it. That purpose I require the A is required, S is required. Okay. So how we are going to calculate? So A I can calculate, A is equal to R2 by X2. Okay, I can calculate. So slip is given directly, is given the slip, 4% is given. Okay, so based on this one, I am going to substitute this value. Okay, now you can substitute this value and do this one. Now you can do it. Okay, so what is the formula? Is asking T is asking the T max, no? So T max by T full load, that is equal to, so what is the formula? A square plus S square by 2AS. Okay, then substitute the value. So what is the A value? A value is equal, what is the R2 is given? R2 is given, what is the value? 0.101 by 0.01, that is equal 1 only. Okay, that is equal to 1. S is equal to 0.04. Simply substitute this value. Okay. Now, what is the value you are going to get it? A square is equal A is equal to 1 square plus S is equal 0.04 whole square divided by 2 into 1 into 0.04. Then by simplifying this value, so I am going to get it nearly 12.52. This is the value is asking, T max by T full load. Okay, T full load. So this is the answer. Okay, this is the answer. We got it. Past is over. So okay, simple substitution equation. Everything is known. It's a simple substitutions. Now next case, what is asking? Speed at which the maximum torque occurs. That means at which the speed. What is the condition, maximum torque condition? So we are going to that. So the speed at which maximum torque, that is condition is equal to Sm maximum slip at which occurred at A, that is equal to R2 by X2. Okay, what is the value here? We are going to get 0.01 by 0.01, that is equal to 1. Okay, then speed, we know that what is the speed? N is equal to formula 1 minus Sm, what happened, into Ns. So that is what is the Ns? Ns is equal to formula 120 F by P. So 120, 50 H is given. What is the P? Number of poles? 8 poles is given. Simple, by simplifying we are going to get it 750 RPM. 750 RPM. Okay, so RPM you got it. So we know this thing, Ns we know, substitute the value. So N is equal to 1 minus Sm into Ns. So substitute 1 minus Sm, what is the value? We got it 1. Okay, so that is 1 into Ns is equal 750 RPM. 1 minus 1 is equal 0. That means speed at maximum torque occurred is 0 RPM. This is the second part. Okay, so what is the first problem? So what he has given is given the data, this one. Based on this one, so we calculated, this is a directive, the formula we know, we derived previous classes and substituted the values. So this is a formula we known, substituted A value, S value in this one. We got the ratio, that is equal. So we are going to get how much value? 12.52 value, we got it. Next, second case, the slip for maximum torque, we know that Sm is equal to A, that is equal R2 by X2, that is equal to 1. So Nr at the speed, rotor speed is equal to 1 minus S into Ns. So here S means maximum speed, that is equal to 1 minus Sm into Ns. We calculate everything, we are going to get the, this is the value. Okay. So finally we got it. What is the answers? So that means one is the, what is the formula? So T max by T full load is equal to T full load, we can write it the 2 full load is equal, we got the 12.52. This is the first answer. Second answer, so Nm, the speed at which maximum torque occurred is equal to 0 RPM. Okay, this is the second case. The problem is simple. How it will simple? So dear students, please remember the formulas. Okay, let us do another problem also. Okay, so what is another problem? Here is the one problem is given, you can do it. Second problem. What is given? Same, you take the motor. Okay, everything is given. So a 4-pole machine P is given. P is equal to 4-pole machine, that is the 1500 RPM, 50 H. Okay, and power is given 7.46 kilowatts machine is given. Okay, big machine. Motor has a rated voltage and frequency. A starting torque is given, T starting torque. Okay, T starting torque, the starting torque of 160% of T full load percent, and a maximum torque T max is given. T max is equal to 200% of full load torque. 200 of full load torque. Full stop. Determine what is required. Determine 1. Full load speed N R is equal to how much? Next, speed at maximum torque occurred, that is equal to N M is equal to these two questions is asking. Similar problems I am going to calculate it. Okay. Here what is the indirectly is given the, so T starting by T full load torque, T maximum by T full load torque is given. So just write the formulas. Okay. These are the values is given. So for finding this required for these values, so we are going to required this here NR is equal, I require the speed, NS is required, the slip is required, here is a is required. Okay. So, here I require the SM, maximum slip is required. Here I require the S is required, SR is a, so rated, then we are going to calculate. So, anyway, I know the equations. What is the equation? N R is equal, rated speed is equal to 1 minus S, okay, S into NS, and NM is equal to, I can write it 1 minus SM into NS. So, that means I know this value is given the, what is the NS? NS is equal to 120 F by P. Okay. So, F is equal 50 H, P is equal 4 poles. So, then I am going to calculate directly the 1500 RPM routine problem, RPM, okay, 120 F. So, I know this value, I know this value, I want the S and SM. Okay. So, how we are going to get this one? So, I require the based on given these conditions. What are these conditions is given? Okay. That means you can take it T taken T starting by T full load is equal to 160 percentage, is kind, we can write it nearly 1.6 percentage. Okay. Now, this is T max divided by T full load is equal to 2 percentage is given. Okay. But we know that this is the first equation, this is the second equation is given. Now, you can write it the 1 by 2. What will happen? 1 by 2. What is the 1? That is a T starting by T torque divided by T maximum divided by T torque is equal to, what is the value? 1.6 divided by 2. Okay. Now, what is happened? Here the torque, this the torque is get cancelled. Then I am going to 1.6 divided by this one. So, I am going to get this. So, as I am doing this simply, I am going to, this value is a 0.08. By simplifying, I am going to this one. Okay. That means, what is the value? Here T starting and T maximum. So, I know that relation between the T starting and T maximum, that is a 2A by 1 plus A square. That formula I know this one. So, that can T starting divided by T max is equal to 0.8. We got it. This is the third equation. Okay. So, but you know this equation, what is the relation? This is 2A by A square plus 1 is equal to, so what is the value? We got it the 0.8. Okay. That is called, so here A square plus 1 plus we did the quadratic equation, we got it. So, from this one I am going to calculate, simplify this one. So, A is equal to, I am going to get it nearly 0.5. Dear students, this is very easy. Simplify 0.8 into A square plus 0.8 is equal to A. So, that we are going to get the A square plus A plus 1, that is equal to 0. One equation we are going to get. From that we are going to calculate the A value. Okay. So, if we got the A value, then we are going to simplify, substitute that value in that equation. Okay. So, now we know that, what is the formula? T full load, that is a T torque, we can write it the, we know that equation. So, another equation I know that, but we require the full load slip is required. So, we know that the T by, you can write it T full load by T max, okay, T max is equal previously with 2 a s, okay, divided by a square plus s square, okay. So here I am going to get it. Now we know that what is the value? This is called T max by T full load by T max. How much we got it? That is called, here we got it that value. So here, so we know that how much you are getting here. So we 1 by 2 we got it. So we previously got it T max by, so already is given, okay na, that value is given na, okay, simply I can so here what is given condition? T max by T full load is a 200% is given, okay. So that here you can see here what is that is given T max by T full load is equal 2%, 200% is given. Here is a reverse, so then I can write it T by T max is equal to 1 by 2, that is equal 0.5, okay. So substitute here, this is equal T max by T is equal 0.5, okay, you can take it, this is equal 0.5 is equal to, so what is the A? A is equal 0.5, you got it. So from this one you got it A, this is a A, okay, 0.5. What is the unknown here? A, yes only, yes, full load torque, full load slip by 0.5 whole square plus s square. Here you can see it, everything is known, only s unknown. So by same quadratic equation s square in terms of s plus 1. So I am going to calculate this s value, okay, the slip under running condition or full load condition. So by simplifying this one, I am going to s is equal to, so 0.134 value, okay. This is a, I know this value. A value known, what is the A value? You got it. So that is equal to, previously we got it the 0.5 na, so that is equal to 0.5 we got it, okay. So that is equal to, we know that, so from this one we are going to calculate maximum slip is equal to A, that is equal to R2 by X2, that's a R2 by X2, okay. So this I know, so Sm is equal to A is equal to 0.5. So from this one I am going to go to the maximum speed at which it occurred, and from this one I am going to get the N, from this one I am going to the NR, from this one I am going to the maximum, this one. Simple substitute, first case, from this one, so N is equal, NR is equal to, we can write it 1 minus S into Ns, okay, that is called 1 minus, what is the S value? 0.134 na, what is the value? What is the value you got it? 134, 134, okay, into, so 4 pole machine, so that is a 4 pole machine means it is the 1500 rpm. Then, so we are going to get it nearly, what is the speed? So nearly we are going to get it, simplifying this one, so 1299 rpm. Dear students, don't confuse it. So I substituted simple equations. This is a 1 minus, this is already we known this equation already we known. Okay, so that is a under running condition NR. So we calculated from this one, substituted in this one, we go with the this is a at that condition the motor speed is 1299 rpm at that load. Okay, now maximum torque at which occurred the speed is required here. Simply substitute here, this is also. Now you can substitute. So here Nm, okay, is equal to maximum slip is equal to 1 minus that is equal to Sm into Ns. Okay, that is equal to 1 minus 0.5 into 1500 rpm. Then I am going to get is simplifying 750 rpm. Okay, so this is the answer. That means what is happened here, so 0 speed, this is a N, this is a torque. So here what is happened, maximum T max, this is a T max. At that condition what is the speed, this is equal 750 rpm. This is equal to 1500 rpm. Under full load condition what is the speed, this is running at the full load condition. So how much, that is a nearly 1300, 1299 rpm. The full load torque, this is a full load torque, this is a maximum torque, this is a starting torque, and the starting torque speed is 0, and at maximum torque the speed is equal to 750. At full load torque, at that is motor is running at 1299 rpm here. Okay, it is asked. So dear students, please practice the remaining problems. So what is given? So he is given simple equations only. Okay, so this problem is given. What is the problem is given? So a 3-phase motor 4-pole has the P is equal 450 H and power is equal 7.4 kilowatts is given. So no need of this one. So but its condition is given, T starting by T full load torque is equal 160%, T maximum by T full load is a 200% is given. So determine the speed at which normal full load condition and the speed at maximum torque condition. So these are the two things I am going to calculate. That purpose is given, this converted this equation into this one, this equation to this one. So based on this one I want the starting by maximum torque in terms I required. So I calculated this is a value. So this is a, because I know this formula, T starting by T max is the formula, well known formula. So substituting these values here going to get the A value. So the A value is the torque at which it is the maximum occurred. I know the A value. And full load torque, so based on this one, so I substitute the T max by T full load by T max is this well known, this is a formula also. You know the A, you know the this relation is given, and based on this one S is calculated. So once S is calculated, S belongs to the full load speed or full load slip. From the full load speed I am going to calculate the full load speed. So these are the two values we calculated. Okay, so similar calculations with the help of the S, with the help of the A. A is regarding to the maximum torque, S is regarding to the full load torque. These are the two things. Okay, so dear students, these are the very simple problems. Just put the formula, get the answer. Okay, so please practice it better to understand overall idea. Okay, if any doubts we will see next class. These are basic things. Okay, so let us summarize what we have seen in this class. So in this class we have seen that So we covered the rotor parameter, the torque developed in the rotor, maximum torque, what is the maximum torque, and the relations among the T and T starting and T maximum, and also we done the some few practical examples. Okay, thank you for listening my class. So practice it. If you have any doubts, so please clarify in the next class.